This video is about the Xor Gate, or the exclusive OR gate. First, let's remember what the OR gate is. The OR gate looks like this, and it has a truth table like this. For A and B, not A not B, Q is false. A not B, Q is true. Not A and B, Q is true. A and B, Q is true. So A or B, but also A and B. So if we don't want to have A and B, we only want to have these ones true, and we'd like this one here to be false, that's what the XOR gate is. And this has a truth table like this. So when they're both false, false, A or B, true, but A and B is false. And we draw it out like this. But how do we implement it? Well, first we express it in Boolean notation. So we can say Q equals, so we can say A or B, A plus B, and timesing by not A or B, because not A or B means that this bit here will be 0, so it can only be these two. So we're going to have our A and B, and we're going to take first to implement this section here, because we're going to put these two together using an AND gate. So first let's do this one. So we have our simple OR gate. A goes in, B goes in, and out comes this part. But then we want a NOT gate, not A and B. So we're going to use our NAND gate like this for not A and B. So B comes in, A comes in as well, and it's got to be both of these at the same time. And that's why we have the normal AND gate, and this is Q, and Q equals this.